Welcome everyone to our Susquehanna Group of Sierra Club General Membership Meeting. We're based in the Binghamton, New York area, and we serve 5 counties. We have technically over 1,000 members, part of the Sierra Club, although just a few dozen are actually active that we tend to see from time to time at our general membership meetings, and even less than that are volunteers such as myself, such as Scott, such as some of the other people, Doug, Jim, who else do I see? Mike Fries, Mary Cronk, Chris Arasta. If I miss, Alan, that's probably Alan Hochberg. Those people are on the executive committee, and they have been working hard to serve our membership, to make these meetings happen, to get relevant speakers and presentations, to do events and activities, to organize protests. A protest bus was actually organized to go to the climate protest in Washington, D.C. a few years ago. Those are big efforts. And I really appreciate the work of all the people on the executive committee. And we are looking for volunteers to submit candidate statements to become a member of the executive committee to help us. It would be a commitment of 1 extra meeting a month, except for in the summer when we take a break, and those executive committee meetings last about an hour and a half to 2 hours, depending on how much material we have to cover. And I would really appreciate it if you do consider this. Please submit a candidate statement, no more than 150 words, explaining what your background is, why you care about the environment, why you think you should be elected by our membership to be on the executive committee. And please submit that by November 10th. And you can submit it to either by mail, Post Office Box 572, Endicott, New York 13760, or by email to Sierra Club Susquehanna Group @gmail.com. This is very important. We're losing at least 1 person from the executive committee, possibly 2. So we're going to have a big void, and we could really use some help. So please consider that. And also I want to mention that next month, November 16th, we're going to have a presentation on farming in Ethiopia and how climate change is affecting that. And that's going to be given by Christina Zavarucha, who is one of the leaders for our local vines, which is involved with community farming, community, I don't know how to, Scott, jump in here. What do you call that?
Gardening.
Community gardening.
Although they do have a farm too.
Yeah, sorry. And then December 21st, we're going to have a presentation by the Southern Tier Land Conservancy that's trying to set aside properties to preserve open spaces for future generations, for everyone to enjoy rather than letting it go to development. There's some other things that are in the works, but we don't have anything else definite yet, but we're going to be trying to get some other speakers for the future too, for next year. So I want to thank you for joining again and listening to me. I'm going to try to cover a lot of difficult material. And if you have a question that you're dying to ask, don't hesitate to interrupt me. But if it's something that can wait, please wait till the end. Climate change, to me, I've been around now for 6 decades of time that I can remember existing. And my parents taught me about nature, so I appreciate nature. And to me, climate change presents the worst threat to humanity in modern times since there was a threat and risk of nuclear war. And nuclear war is actually easier to prevent because there's only a handful of people that control nuclear weapons. As far as nations, yes, terrorists could do something, but that's relatively low likelihood. And most people that are responsible, that are leaders of nations that currently have nuclear weapons, even the ones that we deem irresponsible, they don't want to start a nuclear war because they know that they're going to get things fired back at them in kind. You know, nuclear weapons are going to come back at them too, potentially. So that's easier to prevent. Climate change is this slow rolling disaster that people have been conditioned to ignore and to doubt through mainstream media, through political rhetoric that they hear from their elected leaders. So this is a difficult problem, but what I'm trying to explain to you is what the real risks are that aren't talked about very much, because even scientists are afraid of bringing some of these things up. So anyway, I'm going to share my screen now and start my presentation. And if the right-hand edge of the slides are being cut off, you might be able to change your grid video selection to either get rid of the view of multiple people and maybe just have me showing, then you can see more of the slide. So that might help you. So anyway, I'm going to hide myself because it doesn't help me to see myself. All right, so this is an overview of climate change, where we're at right now. I've got four main areas that I'm going to cover. The first one is a review of the key points from the recent report that came out in August, put together by the Intergovernmental Panel on Climate Change. It's called the IPcC for short. And this report is called the Sixth Assessment Report. They've done 5 other assessment reports on climate before. So this is a major report, and it's worth reviewing what these scientists say. The second area I'm going to cover is self-reinforcing feedback loops and how they can trigger climate tipping points. And then the third area is degrees of warming matter, and even fractions of a degree of warming matter. Fourth area is what has to be done now. And I put an exclamation mark there is because the important point is now. We actually do need to start right now to take serious actions. For people that don't know what the IPCC is, it's an Intergovernmental Panel on Climate Change, was created by the United Nations for assessing the science related to climate change. 195 nations are members. It was established by the UN Environment Program and the World Meteorological Organization in 1988. So basically, we've been talking about this internationally for over 3 decades now. It provides political leaders with periodic scientific assessments concerning climate change, its implications and risks. It puts forward strategies for adaptation and mitigation, and the meaning of mitigate is to prevent the worst of climate change. Thousands of people contribute to the work of the IPCC. Scientists volunteer to assess thousands of scientific papers published each year. This 6th assessment report came out at the beginning of August of this year. It's over 3,940 pages long and was written by 234 scientists from 66 countries, and it cites over 14,000 scientific papers. And a lot of time and effort went into this. So this is the real deal. And the first major point that's in there, I didn't review the entire 3,940 pages. I looked at some of it, but mainly what I reviewed was the 40-page summary at the front of it. The first major point that jumps out at you is it is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. And by unequivocal, they mean clear, unambiguous, apparent, obvious. Cryosphere means all of the ice on Earth. Biosphere means all of the ecosystems on Earth. It's where life exists. And just today, I saw a report done by Cornell University. They reviewed 88,000 scientific papers and determined that there's 99.6% agreement that climate change is real and it's caused by human activity. And that's at a 95% confidence level. So it's no longer, more than 97%. It's more than 99%, more than 99.5%, actually. So there's no doubt, there's no point in arguing with somebody on climate change anymore. If they're going to start arguing, it's just best to move on because you're not going to convince them. This is a chart that came out of their press conference of the IPcC following the release of this assessment report. And it states that human influence has warmed the climate at a rate that is unprecedented in at least the last 2,000 years and likely a few thousand years longer than that, although that's at a lower confidence level. The graph at the left shows you what's happened over 2,000 years. And it was fairly steady for 1,000 years and then started to slowly cool. And what you need to understand is that those many thousands of years, climate was relatively stable, and it was a sweet spot that allowed agriculture to develop, and which allowed human civilizations to get organized and develop. And that allowed people to develop knowledge because they had time to do research and start thinking about how does the world work. So human discovery of science is partly due to the stable climate that we've had. That's worth thinking about. And then at the right-hand edge of that left graph, 1850 to 2020 is where this graph ends. You can see that we countered that little bit of cooling that was happening in a dramatic fashion with the start of the Industrial Revolution, where we started to burn fossil fuels. That's really a telltale sign of what's happened here. It's not, nothing in nature happened that dramatically. It's people, it's humans. Now the right-hand graph is basically that sliver that's shaded on the left-hand, the right edge of the left-hand graph magnified. And there you're seeing from 1850 to now. And scientists have basically set the 1850 to 1900 period as the baseline that they measure global warming to. And then they looked at the average of the most recent 10 years. That's at the right-hand edge, inside the brackets. And when you average that out and you compare it to the 1850 to 1900 average, we've warmed the globe at a surface temperature averaged out over the globe of 1.1 degrees C. And to get Fahrenheit, multiply that by 1.8. The second major point from this recent report from IPcC is that the scale of recent changes across the climate system as a whole and the present state of many aspects of the climate system are unprecedented over many centuries to many thousands of years. And human activities are responsible, dramatically increasing greenhouse gas emissions, which trap heat, and fossil fuel use is the main cause of those greenhouse gas emissions, including the major gases, carbon dioxide and methane. Changing land use caused by humans, namely deforestation and agricultural practices, are also reducing the absorption of greenhouse gases. That's another contributor to the problem we're seeing now. Now this is another slide from their press conference. CO2 concentration is the highest in at least 2 million years. And then sea level rise is now rising at the fastest rate in at least 3,000 years. And from 1901 to 2018, we had 8 inches of sea level rise. And then at the bottom, I added, I can't see my own slide here. I have to do it from memory. It's 0.05 inches per year from 1901 to 1971, and 0.075 inches per year, 1971 to 2006, I believe it was. And then I believe it's 0.15 inches per year from 2006 to 2018, or basically consider it now. So you can see we're accelerating, and that's not good for people. You know, one person from my high school has joined us tonight from Hampton, Virginia. That's a low-lying area, gets high tide flooding. Parts of Florida get sunny day, high tide flooding. There are many places in the U.S. that are at risk from even a little bit of sea level rise. We're also causing a huge loss of Arctic sea ice. In the last 3 decades, we've lost over 40% of the area measured in September of every year of Arctic sea ice. And what's even worse is the volume of ice has gone down even more, and especially the old ice, which is the whitest and most reflective to heat. And when I say old ice, I mean ice that's been there for many decades. That's also dropped. And the Arctic sea ice area is the lowest it's been in at least 1,000 years. The retreat of glaciers globally is unprecedented in at least 2,000 years. So these things that we're seeing are, they're not normal. They're unusual, and they're radically unusual. Now, this is not from the IPcC. I pulled this from other sources, but it's worth looking at. People are constantly measuring CO2 in the atmosphere because that's the main greenhouse gas. And this graph, scientists refer to this as the hockey stick graph, and this covers 800,000 years. And it includes data that's been put together from sampling bubbles of air in ice cores, measured from, taken from miles deep in Greenland ice sheet and Antarctica's ice sheet, and also looking at mud and sediments, and then recently looking at data from when people started to sail across the oceans. People were measuring temperature as well. And then more recently than that, of course, weather, instruments were used. And then now we've got satellite data. So it keeps getting more accurate, but we've pieced together this historical record, and you can see that the CO2 at the right-hand edge, just in the recent period of years, just a matter of half a century, has skyrocketed. So this is a ridiculous amount of CO2 that's being put into the atmosphere. It's billions and billions of tons in a short time period. And the concentration exceeded 415 parts per million in May of 2019. And 2021, it went past 420. And if you look at the chart, the chart ended 2018, then it was 108. So not only is it going up, but it's still accelerating. So we haven't really turned the corner on this, despite talking about climate change being a threat for over 3 decades at the international level. This high a level of CO2 has not happened in over 3 million years. And the last time CO2 level was that high was 1 million years before human ancestors, namely Homo erectus, stood upright, and 2.8 million years before modern humans, Homo sapiens, appeared. And this last occurred during what was called the Pliocene age, and sea levels then were more than 15 feet higher during most of it, and at some parts of it, it was over 200 feet higher. So we don't want to get back to that point, but we've already got an atmosphere that can make it get there if we don't change it. Third major point, human-induced climate change is already affecting many weather and climate extremes in every region across the globe. Evidence of observed changes in extremes such as heat waves, heavy precipitation, droughts, and tropical cyclones, and in particular, their attribution to human influence, has strengthened since AR5. And AR5 was the 5th assessment report on climate from the IPcC, and that came out in 2014. So the next 3 slides are maps that are stylized, and they took the world map and put it into sort of equal areas based on hexagons. And so North America is at the top left, South America is at the bottom left, and then we've got Europe and Asia at the top right, and Africa at the center, the bottom center, and then Australia at the bottom right. So these three slides in a row here use the same map basically and color different shades depending on what they're trying to show. And the dots that are in there talk about how much confidence there is in the condition that the chart is trying to show. If it's got 3 dots in a hexagon for that specific area, there's high confidence that what is being shown that is colored in, like most of these are red, for an increase in heat waves, hot extremes. If it's got 2 dots, that means it's medium confidence. If there's 1 dot, it's low confidence due to limited agreement. And then if it's an open circle, it's low due to limited evidence. And what's apparent is that almost every major region across the planet has got worse heat waves going on. They go to higher temperatures and they last longer. They're more severe, all except in a few areas: Central North America, Eastern North America, Southern South America, and Central Africa are the only places where that's not apparent. Also, we're seeing heavy precipitation events increasing. They're getting higher volume of water coming, in other words, rate of water coming per unit of time. In other words, inches per hour of rain or snow. And also sometimes we're getting storms that get stuck. So you might get 2 or 3 days of really heavy precipitation. So that's what we're talking about here with heavy precipitation events. And again, significant areas of the world are seeing an increase in heavy precipitation events, and no place is it seen a lowering of heavy precipitation events. The third slide here talks about drought, and people familiar with California, the Western North America there on the top left, that's what's yellow, that's an increase in severe drought and the longer time periods of drought too. You can also see Western Europe, the Mediterranean, Middle East, East Asia, huge areas of Africa, even Eastern South America, parts of the Amazon are now starting to see drought, and then Southern Australia as well. The only place where you're seeing a decrease of drought is Northern Australia, which happens to be mostly a rainforest. So luckily for there's less drought happening. So what's in common with these 3 slides is that all 3 of these heavy precipitation events, droughts, and more severe heat waves harm the ability to farm. And so this is something to bear in mind for what we're going to talk about later. This is another way of looking at it with pretty pictures. We've got extreme heat, and I looked up the information in red. What extreme heat, what the consequences are: 489,000 extra deaths due to heat waves per year. 489,000 deaths around the world per year. This is from 2000 to 2019 data from the Lancet Planetary Health. The article or report came out July 2021. And then in the United States, the death risk due to heat waves is up by 5 to 10% in the time frame of 2000 to 2006. It's from the same article. We've got heavy rainfall, more frequent, more intense. That causes deaths, building damage, crop losses. We've got drought in many regions, and that also causes crop loss and results in migration. When farmers give up after many years of drought, they start moving to look for work, to try to send, even if they send one person, maybe that person is an older, or not older, but a young person, but old enough that they're not in danger of being killed on the way or getting lost, but they're old enough to work and send money back to the family. And this can lead to conflict and deaths. We've got fire weather now, which, is causing huge areas that are hundreds of thousands of square miles to burn. And we've got zombie fires going on in even the Arctic forests and Arctic tundra. It starts to diminish in the winter with some snows, but still simmers on in embers below the surface, and then flares back up again when the warm period comes again in the spring. And these fires are causing building damage, deaths, they're causing crop losses in some areas. We've got the ocean warming, acidifying, becoming more acidic, which harms the ability of sea life to build structures, to build shells, to build scales. And the oceans, with the warming, it's losing the ability to carry enough oxygen for many types of fish and sea life as well. So this also threatens food supply and a big source of protein. And this can also lead to conflict. The next section is on self-reinforcing feedback loops, which can lead to climate tipping points. Strong self-reinforcing feedback loops can quickly amplify small changes. This happens when a change in A leads to a change in B, which in turn produces more change in A, and so on. An example of this that people are familiar with is when you hear feedback from a microphone and a loudspeaker being too close to each other. The noise picked up by the microphone is amplified by the speaker, and then that's picked up by the microphone again and amplified again until you reach a screech, and that's when the amplifier gives up and gets saturated. So these things are not good in the climate system, to put it mildly. Self-reinforcing feedback loops are also called positive feedback loops. I studied this in my chemical engineering control theory in way back in the 70s and 80s. So this is a familiar topic. Anyway, here's an animation of what a certain type of positive feedback loop, self-reinforcing feedback loop in the climate system, and it's called the ice albedo effect. And what happens is, with increasing temperature, you melt sea ice, then you've got less sea ice covering the dark sea surface, and when you expose more dark sea surface, that water absorbs more heat. Bright white ice reflects heat, reflects infrared energy. So the darker sea surface absorbs more heat, which then melts more sea ice and increases the temperature of the water surrounding it, and it just keeps on going in a self-reinforcing feedback loop. So that's one self-reinforcing feedback loop in the climate system, and that can push this system to a tipping point beyond which it's hard to get back. If you melt all of the ice in the Arctic, with all that dark water exposed, it's hard to get ice to refreeze again if it's too warm. So this is something we need to watch out for. Here's another animated graphic. When you get to a tipping point, until you get to that tipping point, it takes effort to push something to go beyond this point. And then once it gets past that point, it kind of gets a life of its own and keeps on going. And then even if you remove the pushing mechanism, what was causing it to happen, it still keeps going. So you can think of it as a seesaw. So it's the critical threshold is that pivot point. And once you get past that, it keeps on going on its own. In the climate system, there are many self-reinforcing feedback loops and many climate tipping points. And this graphic of basically a map of the world shows 7 major ones. There's sea ice loss, what we talked about in the Arctic. There's Gulf Stream current slowdown that's in the Atlantic Ocean. There's Amazon forest dieback. There's El Nino strengthening in the Pacific Ocean. There's ice sheet collapse in the Antarctic. There's weakening of monsoons. And then there's a big one, permafrost methane. And that's the one that really is why I wore this shirt. I don't know if you can see it if you've turned off the views, but anyway, it's a picture of a bomb with a fuse, and it's got climate change at the bottom with a hashtag. And that's the methane bomb that we don't want to have triggered. I wore that to an event already in front of TV cameras. The Gulf Stream's slowdown could result in the shutdown of the Atlantic Meridional Overturning circulation, which is a big circulating current system. It circulates, looking at the map from the perspective of looking down at the Earth, you can see it sort of as a big circle, but it's also vertically too. It's moving cold water and warm water near the surface, cold water from down below and warm water at the surface. So it's doing a lot of things, and this current interconnects with other currents that wrap around the globe. So it's a big deal if we affect these currents. And this Gulf Stream is slowing down due to fresh water melting from the glaciers on Greenland, melting and sliding into the ocean. So that's slowing them down. And it's slowing the Gulf Stream down, the flow of water in the ocean down. And this could result in less warmth for Northern Europe, as well as higher sea levels in the Eastern US, because if you've got less current carrying the warm water away from the coast of Florida and the other coastal states north of Florida, then that water has more chance to warm up even further, and warm water expands. So locally, you can get an expansion of the ocean water, which raises the sea level locally. It might be hard to picture that happening, but the sea level is not an average smooth sphere. It's different due to gravitational effects next to continents. It's higher there too, and it's also affected by how warm the water is. So there's bulges in the level of the oceans in certain areas. So that's another thing that it's normally isn't talked about, but it's real. Another major problem that we face due to self-reinforcing feedback loops that could also trigger a tipping point of the climate is Amazon rainforest dieback. And that's caused by slash and burn agriculture spreading into what was rainforest and decreasing the rainfall there. And this rainforest ecosystem could fail and switch to savanna. And if that happens, we could release a large amount of carbon. And recent studies already are reporting that areas of the Amazon may now already be starting to release more CO2 than they absorb. And this picture shows what used to be rainforest. It's now fields dotted with a few trees, and then you've got some sections where there's still big trees left, but roads are being cut farther and farther into the rainforest, and much of it is being cut down and then logged and burned. The scraps are burned, the logs are harvested, and the soil is very, very thin, and it doesn't really support agriculture very long either. It's not a very fertile soil. So it's crazy to keep doing this, but yet people are. Another problem is ice sheet collapse. That's another self-reinforcing feedback loop that can lead to a climate tipping point. Many ice sheets, especially in Antarctica, are what they refer to as grounded. In other words, they are resting on a slope that rises under the sea level. In other words, below sea level. So even though the center of the continent, there's areas that are really high in terms of the land mass, then when you get out farther from the center, you've got areas where it's actually below sea level, but filled with ice that's so heavy because there's miles of ice that are higher than sea level that are pushing down what's below sea level at the bottom of the ice sheet, and that's making it have a high degree of friction on this slope down below. So that's basically held back a lot of these ice sheets and slowed their motion. But as more of this ice sheet melts away underneath from the warming of the ocean around Antarctica, there's less friction because there's less contact between the ice sheet and this slope, this rising slope, this ridge. So the less friction there is, the faster this ice sheet is going to move. And if all of it starts moving, if you've done a simple experiment in physics where you use a spring scale and you measure the force it takes to make something start sliding, once it starts sliding, on a slope, a weight on a table that's at an angle, once it starts sliding, it's liable to keep sliding if the slope is great enough. And what the slope I'm talking about is not the slope you see in this chart that's a side view, but the slope farther back, which has got thousands of miles of slope that is downhill towards the ocean. So this small slope here is uphill at the, underneath the ocean, where the ice sheet is the edge of the ice sheet is. So this could lead to rapid sea level rise. So we don't want to have this happen. And West Antarctica, there's an ice sheet there that's in danger of this happening. And there's also one in East Antarctica. I think the West Antarctica one is called Thwaites ice sheet. Another one that I mentioned briefly is the thawing of permafrost. It's a monstrous worry. Climatologists are all worried about this. They're worried to death about it. There's a lot of methane trapped as frozen gas in seafloor sediments and also in permafrost on land. Global warming could cause these deposits to melt, and beyond the melting tipping point, this could become self-perpetuating and release large volumes of greenhouse gases that would further add to global carbon emissions. Methane is a gas that's 85 times as bad a greenhouse gas as CO2 in the first 20 years after being emitted into the atmosphere. And we don't want to have this supercharged gas go along with the CO2 that we're already spewing into the air. This would be a disaster. And also another thing that can happen with thawing permafrost is those dead plants and animals that are in there, they could start to compost, which can also then cause more CO2 and methane gas to be released. This frozen ground holds a vast amount of carbon accumulated from dead plants and animals over thousands of years. There's around twice as much carbon in permafrost than is currently in the Earth's atmosphere. So imagine if you triggered the release of this, it overwhelms what humanity is already releasing. So this would be a monstrous disaster. This chart, I don't intend for you to understand it. There's a lot on here, but the point is that the climate system is very complicated, and this is even a simplified version of it. And this shows many tipping points and self-reinforcing feedback loops. The blue ones are related to ice. The red ones are related to circulation patterns in the oceans as well as in the air. And then the green ones are related to biosphere. One of them that we talked about was the Amazon rainforest. The third section of this talk is covering the fact that every degree and fraction of a degree can make the situation much worse. Degrees of warming matter. It matters how much we warm the atmosphere. People might say, well, 3 or even 2. Well, the problem is that it's not even around the globe. This 1 or 2 degrees is averaged. It's much worse in the Arctic when, as I already mentioned, the thawing of the permafrost and the melting of the Arctic Ocean, those are big deals. We don't want to have them continue. And we don't want to have the permafrost get to the point where it's past the tipping point of melting. Some of these tipping points could trigger each other in a cascading domino effect, leading to global warming being amplified towards a hothouse Earth. And I will talk about this a little later, but keep in mind that topic, that point, that term, hothouse Earth. Here's another chart that talks about dangerous dominoes. Degrees of warming matter, the tipping point cascade at the heart of the hothouse Earth hypothesis. And I give the source here, Stefan and others released 2018. And in yellow, these tipping points are at risk at 1 to 3 degrees C of average global warming. The ones in orange are at risk of being tipped at 3 to 5 degrees. And then red, 5 degrees, those are disaster. It's the winter sea ice might totally disappear in the Arctic. The permafrost, as I mentioned, could completely melt and release huge, vast quantities of methane and CO2. And then the East Antarctic ice sheet, if that starts to collapse, after we already make the West Antarctic ice sheet collapse, we're talking, hundreds of feet of sea level rise at that point. At that point, it's game over. Again, another source of information that I got used was Climate Nexus. They've got some nice charts. Again, I'm trying to show how degrees and fractions of degrees of warming matter. At the Paris Agreement, which was agreed by international countries, internationally in 2015, they agreed to a 1.5 degrees C stretch goal of limiting warming to that. And if not that, then certainly we don't want to let it go past 2 degrees C. And talks began seriously in 1992. So we've been basically talking, country to country internationally, with as many as now 195 countries participating for almost 3 decades. So that's why Greta Thunberg is so upset, and she really lets them have it, because she says the time for talk was over decades ago. And she wants to see action, and I don't blame her, because we do need action and we know what to do. We're just not doing it. At 3 degrees C, if countries fulfill their meager Paris pledges that they made prior to 2021, we might get to 3 degrees and maybe even past 3 degrees. And that's if they fulfill their pledges. But we're not fulfilling the meager pledges that were made. And when I say we, I say countries. And so we're actually headed to 4 degrees or possibly even 5 degrees, because there's not enough action being taken. And as I mentioned earlier, greenhouse gas emissions are still accelerating. And the consequences are, there are several of them, but anyway, the first one is sea level rise. At 1.5 degrees C, rising sea levels would displace 46 million people. The sea level rise would be roughly 0.5 meter, 1.7 feet. And this is out of the IPcC recent assessment report. At 2 degrees C, there's fewer opportunities for infrastructure adaptation. There would be about 2/3 of a meter, 2 feet of rise of sea level. At 3 degrees C, you'd have near complete melting of the Greenland ice sheet. I can't read what's on there because it's blocked. I don't know if I can fix this. But anyway, you can read it yourself. 4 degrees C, there's 470 to 760 million people at risk. Sea level rise would be almost 9 meters, which is almost 30 feet. And we're talking 500 million to 750 million people would have to move. You imagine what would take there? The major cities would have to start being abandoned, huge areas of Bangladesh. There would also be impacts on water. There would be water shortages in the Mediterranean, Australia, Brazil, Asia. We're already seeing water shortages from the Colorado River system. They're cutting back water supplies to the California and other areas that the Colorado River supplies. 2 degrees C, we have 8% of the global population facing severe water shortages. At 3 degrees C, almost half of the Himalayan mountain glaciers would be lost, and they feed major rivers that farmers depend on in India, as well as Western China and Central China, and even Vietnam. 4 degrees C, you'd have more frequent and severe droughts. There would be big impacts on food. At 1.5 degrees C of warming, we'd have a drop in food production of wheat by 9%. Corn would drop by 3%. Other cereal grain production would also suffer, and the marine fish catch would drop by 1.5 million tons per year. The farm yields would fall quickly at 2 degrees C. Wheat would then drop 16%. Corn would drop 6%, and marine fish catch would drop 3 million tons per year out of 155 million tons per year that are caught from the oceans. So you might think, well, that's small, but many countries, the bulk of the protein that people get is from what they catch out of the ocean. So it is a big deal. Fish species would go extinct locally at 3 degrees C. At 4 degrees C, high levels of food insecurity, starvation, development path of third world countries would be reversed. There would also be impacts on flora and fauna, on plants and animals. 1.5 degrees C, we'd see 90% of coral reefs would likely die or severely degrade. And that's big habitat for diverse ocean life forms, including fish. So that's a big deal. At 2 degrees C, 99% of coral reefs would die. At 3 degrees C, we'd have marine ecosystems that might collapse. At 4 degrees C, half of all plant and animal species face local extinction. An international study published May of 2019 found that there's a 1 in 20 chance, a 5% chance that sea level rise would be over 7.5 feet by the year 2100 if emissions remain mostly unchecked, and we would end up with a 5 degrees C rise in global temperatures. This is by 2100. So this is the end of this century. So our children are certainly going to be alive at this point, and that would be horrific if we let that happen. An area 3 times the size of California would be inundated. There would be about 200 million climate refugees. 1 million refugees already have migrated to Europe from the Syrian crisis, which was partly due to climate change that caused a 5 to 6 year drought in Syria. Washington, D.C., New York City, London, Shanghai, other major cities, as well as about a quarter of Bangladesh would be at risk of being unlivable. And this graphic here is a picture of the Jefferson Memorial, an aerial view. And I used Google Earth to simulate a rise of 7.5 feet. And you can see the blue almost completely surrounds the Jefferson Memorial. Here's another one that was published in The Guardian. Climate Central did this. They have views of many places around the world that are, famous and not so famous. This is the Lincoln Memorial. Would end up being almost an island if we allow 3 degrees C of global warming, and we'd end up with 7 feet of rise of sea level. That's after about a century. Warming is accelerating, and as I mentioned before, emissions are still accelerating. This is a graph of a measure of how much heat the atmosphere is retaining and the Earth system is retaining. It's measured by a satellite named Ceres that looks at the top of the atmosphere radiation, and that's in orange. And the blue is from floating buoys in the ocean measuring heat uptake by ocean water. Oceans are absorbing 90% of the excess heat energy retained by Earth's atmosphere. So what this shows is that we've increased the amount of heat that's being trapped by the Earth by 50% just in the time period of 2005 to 2019. That is just astounding. It is super scary. It's horrifically frightening. And we're lucky that the oceans are absorbing 90% of this, because otherwise we'd already have temperatures that would be lethal on this planet in many areas. The oceans are now absorbing 5 Hiroshima atomic bombs per second in equivalent heat. And that was reported in many places at the beginning of 2020. The CNN was the place I picked that up from. So that's another statistic to remember. Unchecked climate change risks breakdown of human civilization and a thermal runaway to hothouse Earth. This section is the most scary topic And you won't hear mainstream media talking about it. But this is why there's an organization called Extinction Rebellion. And they're labeled as radicals, but they're protesting for a real reason. There's a 1 in 20 or a 5% chance of this happening. And it's really difficult to predict what would happen with public opinion and politics and governments and countries and how they interact with each other. Climatologists certainly can't be expected to predict this, but we must talk about it and we must consider it, because this is our main problem. This is why we haven't taken action, despite organizing internationally and discussing this as a concern for almost 3 decades now. So it's worth talking about this. So that's why I'm bringing it up here. Sorry if it makes you depressed, but you need to be depressed about this. I hope it spurs you to action. How climate change could lead to breakdown of human civilization has been analyzed, and a theorized scenario of how this might unfold has been written up but in a paper by David Spratt, a climatologist and research director, along with Ian Dunlop, a former fossil fuel industry executive. It was published in May of 2019 by an independent Australian think tank that is called the Breakthrough National Centre for Climate Restoration. It's based in Australia at Melbourne University. And this paper was titled Existential Climate-Related Security Risk, a Scenario Approach. It sounds like a bland title, but what they're talking about is the potential for the end of human civilization. So anyway, we'll go through it. They're just summarized. Bear with me here. This is the introduction. I pulled out a few key quotes. Climate change intersects with pre-existing national security risks to function as a threat multiplier and accelerant to instability, contributing to escalating cycles of humanitarian and socio-political crises, conflict, and forced migration. Climate change impacts on food and water systems, declining crop yields, and rising food prices driven by drought, wildfire, and harvest failures have already become catalysts for social breakdown and conflict across the Middle East, the Maghreb, which is northern Africa, and the Sahel, which is a broad east-west swath of land just south of the Sahara in Africa. And this is contributing to the European migration crisis. Now, this is the scenario itself. So the first decade, 2020 to 2030, policymakers fail to act on evidence that the current Paris climate agreement path, in which global human-caused greenhouse emissions do not peak until 2030, they result in locking in at least 3 degrees C of warming. Actions needed to keep warming below 2 degrees C are not taken. By 2030, carbon dioxide levels would have reached 437 parts per million, which is unprecedented in the last 20 million years. Not a few million years, but 20 million years. And warming reaches 1.6 degrees C. That's by 2030. That's just 8 years away, basically now, or 9 years away. It's not that far. And then 2030 to 2050, the next 2-decade period, emissions begin to peak in 2030 and then start to fall, consistent with an 80% reduction in fossil fuel energy intensity by 2100 compared to 2010 energy intensity. This leads to warming of 2.4 degrees C by mid-century, by 2050. And this is consistent with two people, Zhu and Ramanathan, who proposed a baseline fast scenario. However, another 0.6 degrees C of warming occurs, taking the total to 3 degrees C by 2050, due to the activation of a number of carbon cycle feedbacks and higher levels of ice albedo and cloud feedbacks than current models assume. Many of the models that are in the climate change, they only want to use the ones that they have high confidence in. But some of the models that they're not, putting into the summary also talk about things that could be worse. At 2050, tipping points for ice sheets, widespread loss of permafrost, and Amazon large-scale drought and dieback have been passed. At this point, we have arrived at the hothouse Earth scenario. It has been realized, which then would mean the following consequences. 35% of global land area and 55% of global population has over 20 days per year of lethal heat. That means you can't be outside. for more than just a handful of minutes in some places. The jet stream has destabilized, severely affecting Asian and West African monsoons. Gulf Stream slows further, severely affects Europe, hurts their ability to farm. North America has devastating weather extremes, wildfires, heat waves, drought and inundation, flooding, deadly heat conditions persisting over 100 days per year, more than a quarter of a year each year in West Africa, tropical South America, the Middle East, Southeast Asia. Over 1 billion people would be displaced from the tropical zone. Imagine if you're worried about, people, migrating across the southern border of the U.S. now. Just imagine what would be happening then when you've got 1 billion people migrating just because of heat waves. You've got another, billion people because of flooding of coastal areas and major cities. I mean, this would be just absolute chaos. Water scarcity would affect 2 billion people worldwide. And this is not even the full impact list. Sorry if that depresses you, but as I mentioned, it's worth considering. What happens at the end of that is that food production is inadequate to feed global population, and food prices would skyrocket due to 1/5 decline in crop yields, and there will also be a nutrition content decline of at least 15% of food crops. So even if you can get food, it's not going to be as nourishing. There would also be a catastrophic decline in insect populations, even more than what we've already seen. We'd have massive spread of deserts, monsoon failures, chronic water shortages with conditions too hot for human habitation in significant food growing regions. Civilization collapse is likely at this point. Even with 2 degrees C of warming, 1 billion people may need to relocate. Don't give up hope, though. We have a choice for a better future, and that's the rest of the presentation. So we're almost at the end here. What has to be done now? Some people are still asking questions, but we actually do know what needs to be done. The exclamation mark is the fact that we actually need to get going. The good news is we have the technology and the economic ability to save a habitable climate. 2 major strategies need to be implemented to address climate change in order to minimize its harmful effects. We need to start now with appropriate scale of effort and urgency. And what we mean by that is World War II scale and speed. We need to have that kind of effort and cooperation across countries around the world. And the United States needs to be a leader on this, because we have actually been one of the leaders in terms of, for us over a century, being the leader in terms of emitting greenhouse gas emissions. China has only recently caught up to us. And so blaming China is not the answer. 2 strategies: adaptation, which is adjusting to new conditions. If you imagine you're on a boat and it starts to leak, you can adapt by bailing water out of the boat to stay afloat. Mitigation is the other major strategy, and that is addressing the root cause of the problem in order to prevent it from getting worse. And the leaking boat example is you patch the leak in the bottom of the boat to either stop the leak or at least minimize the leak so that you keep it from getting worse. Some things we can't stop from happening because we've already baked in a major amount of change in the climate, but we can prevent it from getting to this disaster of the hothouse Earth with breakdown of human civilization. So it's worth taking action. It really is. We need to take action. We don't despair. Use your worry to feed action, and I'll get to what you can do. But first of all, things that we can do for adaptation. Examples are building seawalls, elevate and harden infrastructure, elevate things like transformers and switchgear for parts of the grid, water systems, things like that, pumping stations. U.S. cities like Charleston, Houston, Miami, San Francisco already have billion-dollar investments planned to protect their seabound populations. They're raising streets and sidewalks in South Miami because of the flooding just from high tides. Reduce and reduce use of and recycle water to address drought. Spain, which has lost 20% of its fresh water in just the past 20 years, has made significant changes to its national water policy. And we're being forced to do this for areas that use water from the Colorado River system as well, because the reservoirs behind the Hoover Dam and behind the Glen Canyon Dam are at record low levels. They're at the lowest levels they've been since the reservoirs started to be filled after the dams were built. So this is just, it's very dramatic change. It hasn't been at those low levels since the dams were built. We can switch to more drought tolerant crops like rice, cowpea, and corn. Many African countries have already done this in response to decreasing rain. We can use prescribed fires to minimize the damage from uncontrollable wildfires. Southeastern United States is already doing this. And it's no surprise that this practice is increasing in the region, given that by mid-century, the National Oceanic and Atmospheric Administration, NOAA, suggests that the risk of very large fire weeks will increase by 300%. The second major strategy is mitigation, prevention of the worst of climate change. And there's two ways to do that. Reduce greenhouse gas emissions is the first way. In October of 2018, the IPcC warned after those talks were over that we need to cut greenhouse gas emissions 50% by 2030, and we need to get to net zero by 2050 to try to limit warming to 1.5 degrees C. To do that, we can reduce energy use via efficiency improvements. We can electrify everything based on clean energy and get off of fossil fuels. We can use regenerative agriculture with localization of agriculture and delivery to local markets, and also a change in diet. Eat less meat. Switch to grass-fed beef if you insist on eating beef. Phase out powerful greenhouse gas chemicals. There are two big ones. Hydrofluorocarbons are in air conditioning and refrigeration systems. The main culprit is HFC 134A. It has a 15-year life. It's 3,000 times as bad at global warming potential compared to CO2. 150 nations signed what's called the Kigali Amendment to reduce the use of this by 80% by 2047. And this, if nations do this, it can avoid 0.4 degrees C of warming by the end of the century. And remember, 0.4 degrees C is a big deal. Sulfur hexafluoride, SF6, used in high voltage switchgear. This is an insulating gas to prevent arcing when they open switches that control many thousands of volts in high voltage lines. This gas lasts thousands of years, and it's 23,500 times as bad as CO2 at causing global warming. The global emissions of this gas are equivalent to 100 million cars driving on roads. So there is no agreement on this yet, but there are people calling for this to be phased out, and I hope that they, phase it out, and that there is an international agreement soon. This is something that you can ask for from your elected leaders. The second major thing we can do is enhance absorption and sequestration, in other words, storage of greenhouse gases. Big one for that is plant trees, stop deforestation, stop cutting down huge sections of forest. We can also use regenerative agriculture to help soils be more healthy so they can store carbon. Examples in more detail of mitigation. Replace fossil fuels like coal, oil, and natural gas with clean renewable energies like solar, wind, geothermal, wave energy, etc. Luckily, renewables became the cheapest form of new electricity generation across 2/3 of the world in 2019, compared to in just 1% of the world 5 years earlier. So renewable energy keeps getting cheaper, and it's gotten so cheap now that it's cheaper in 2/3 of the world than building new fossil fuel-fired electricity generation plants. So there's no economic reason even to not rely on renewables now. Replace traditional internal combustion engine vehicles with electric options, ideally charged with renewable energy. Electric vehicles are improving, as Bloomberg NEF describes. Over 2 million electric vehicles were sold in 2018, which is up from just a few thousand in 2010. And in 2020, just 2 years later, 3 million were sold, and it's still climbing, which is good. We can retrofit old buildings to make them more energy efficient by adding insulation, making the windows more less drafty, better weather stripping and sealing. This is a fast-growing industry worth $300 billion globally. So this is what represents jobs. We can plant trees and preserve forests so they can absorb and store more CO2. An example of this is the Indian state of Madhya Pradesh planted 66 million trees in just one day. And the credit for these example slides are the Climate Reality Project. This is another slide from the Sixth Assessment Report press conference slides. This is showing the choices we've got. Future emissions cause future additional warming. So where we're at is the gray vertical bar in the middle here. Basically, we're talking about 2020 to 2040 that we need to take the most action in. And what the Paris Agreement is proposing is that we can keep the warming to less than 1.5 degrees C if we act really urgently in a very high, level of big scale of action. We can hold it to less than 1.5 degrees C. And if we do a less drastic change over to renewable energy and the other things I just mentioned, then we can at least try to hold the warming to less than 2 degrees C. So that's the choices we want to aim for. We don't want to have the yellow, the red and the dark red, the very high scenario. Those two, even the yellow, those things could, those upper three rising graphs, they don't start to taper off for centuries or even millennia, thousands of years. And those are the ones where we end up with potential breakdown of human civilization and loss of the climate system. So some bad effects are already baked in and will continue for centuries and may get worse slowly. But if we make substantial and rapid changes to lower emissions, we can prevent the horrible scenarios that I just finished explaining with that hothouse Earth and the breakdown of human civilization. With every additional amount of global warming, the changes get larger and worse. At 1.5 degrees C, this is what the map of the actual surface temperatures of the Earth would look like. And you can see the Arctic is much worse at around 5.5 degrees C in many areas. At 2 degrees C of average global warming, the Arctic gets hotter, and many areas where people live get hotter as well on average. The Arctic, some areas would then get 6.5 degrees, some areas 7 degrees, which is horrific. Remember that can really trigger a lot of melting of the permafrost, which is the big climate bomb that's on my shirt. Then 4 degrees C, all of the permafrost is going to be melting away, and the ice sheets are all going to be sliding into the ocean. So we can't let that happen. And then these are some things that you can think about and resolve to do. Do what you can personally, but push for system change. Don't feel guilty if you don't do all of these actions that I suggest that you do personally, but please at least push for system change. Because just acting individually is not enough. There are massive things that individuals can't make happen. Ideas for individuals include signing up for renewable energy. You can get 10 to 20% savings just by making a phone call and changing the supplier for your electricity. This is easy to do. And there's companies that offer 10 to 20% discount with no long-term contracts. If you don't like it for some reason, you can switch back or try a different one. You can weatherize your home. You can switch to air source heat pumps or geothermal for heating. You can combine trips rather than going for every little thing you need. Just go to one store and then you come back home and then, oops, I need to go someplace else again. Try to plan it and just plan it out so that you combine multiple stops to one trip. You can use public transport. You can bicycle. You can make your next vehicle purchase an electric vehicle. You can switch to LED light bulbs. You can reduce and eliminate your eating meat. All of these things can help. But again, we need to push for collective action. We can't solve it as individuals. Another thing you can do is press for industry action. You can contact companies and ask them, what are they doing about their greenhouse gas footprint? And if you don't like what they're doing, you can boycott them. You can divest. If you've got investments in mutual funds or stocks, you can sell those investments in that are in bad firms, especially the fossil fuel industry. You can get your investments out of those. The biggest thing that I want you to take away from this presentation is that please push for government action at appropriate scale and speed. And again, like I mentioned, it's what we're talking about here is World War II scale of speed and action. Contact government officials by letter, email, or phone. Tell them what town, city you live in and the zip code where you're at. And that climate actions will determine your vote and your level of support for that person, that government official. They count these phone calls. They count what the phone calls are about. So it does matter if people call, and you can't just leave it up to activists. There's not enough activists. We need everybody to do this. Do it at federal, state, and local levels of government, and keep doing it. Don't just do it once or twice. Do it once or twice a week, or at least a couple of times a month. Keep telling them. And if legislation is changing, tell them what legislation you like, what changes you like. Tell them what you want to see them pass in terms of legislation. Example, at federal level, we've got this Build Back Better Budget Reconciliation Act that has a huge amount of climate policies that are really good. And the main one that I mentioned really early in this tonight's meeting was the Clean Electricity Performance Program. It's $150 billion program that would use incentive payments if electric generation utilities switch to renewable energy, and penalties if they don't switch to renewable energy on a certain timeline, and if they start building more fossil fuel fired power plants. Unfortunately, as I mentioned earlier, Joe Manchin is against this. But if you've got people in West Virginia, tell them to call Senator Manchin's office and tell them to say that we want this bill passed and we want that Clean Electricity Performance Program in it. At the state level, for New York State, the Climate and Community Investment Act is a big one that we missed. It didn't happen this year, even though it was talked about. We need to have it happen next year. It has to be pushed more. So call your local representatives in Albany. Help good candidates campaign. Donate to their campaigns. Help people register to vote and vote yourself. And maybe if somebody needs a ride, give them a ride to go vote. Cost and jobs are not valid excuses. Extreme weather, climate-related disasters are already costing U.S. taxpayers $99 billion in 2010 and $100 billion for just the first 9 months of this year. U.S. jobs in 2018, there were 335,000 solar jobs and 111,000 jobs in wind energy. That's 446,000 total compared to only 211,000, less than half in fossil fuels. Renewable energy jobs are growing faster as well. Fossil fuel air emissions are causing 1 in 5 deaths, which is 8.7 million per year globally. That's was reported in Yale Climate Connections, April 2021. And in the United States, fossil fuel air pollution results in 350,000 deaths per year. And another thing that you need to know is benzene, which is a powerful carcinogen, is allowed in gasoline at 0.6%. It's also in diesel fuel. So anytime you go to a gasoline station and fill up your internal combustion engine powered vehicle, you're exposed to this. And if you live near a gasoline station, you're exposed to this much of the time. Another thing you can do is protest. I've been to more protests than I can count. Tell your friends, relatives, coworkers, neighbors, etc., about the climate change crisis and the need to contact officials. You can volunteer with groups such as the Sierra Club. Indivisible is another good group. Citizen Action in New York State is a good group. Locally in the Southern Tier here, they do a lot of good work. They organize a lot of protests and media events and promote renewable energy. There's the Network for Sustainable Tomorrow. Used to be called Binghamton Regional Sustainability Coalition. That's another good organization. There's other national groups too, Greenpeace. There's the Young People's Group, Sunrise Movement. There's Sane Energy Project in New York City. So find a group that's in your area and you can volunteer with them, or maybe even over the internet. They have Zoom meetings too. At least donate money. A better world with a habitable climate, cleaner air and water, better health, better jobs, and quieter streets is possible. So there is good news at the end of this talk, even though I took you through a depression. So anyway, are there any questions, ideas, comments? What did you think of this presentation?
Well, I'll make one. Thank you very much, Valdi, for showing us all these things. I think perhaps we know a lot of it, but you've produced some very nice data and sources too. I've been taking down your sources. But I do have a point, a very local point. There is a debate Thursday night for mayor of Binghamton, and it would be very nice to have pointed questions delivered to the candidates. The city has actually had a climate change action plan ever since the Ryan administration 8+ years ago. As far as I know, very little attention has been paid toward it in the last 8 years. It's time that we really just adopt that climate change plan and follow it.
Good point. Yes, I missed the days of Matt Ryan. He was a good mayor, and we do need another good mayor here. So anybody that lives in Binghamton, please submit ideas for questions and support the endorsed candidate, Joe Burns. It's endorsed by Susquehanna Group, our local group here, as well as the Atlantic chapter of Sierra Club, which is the New York State group. And I see Bruce Gillette has his hand up. What would you like to say, Bruce?
I think your presentation was excellent. Very well done. Could you make the slides available to us so that we can get some of the data you had, looks like hyperlinks to things, and it would be helpful to be able to check out some of your sources to get further information.
We can try to make that happen. At least the recording of this presentation will be made available, and you can also contact me directly, Bruce. We've already been in contact anyway. So
Sure.
if we have trouble putting this slide presentation available so that the links work, then I'm sure we can do it as a PDF document pretty easily. But I don't know if the hyperlinks would work at that point. I'm not sure.
Give it a shot.
But
thank you.
Yeah. All right.
You might want to take off the screen share now so you can see more of the participants.
Good point. I had I ran a little long, but if people don't have much in the way of questions, I have a 2.5 minute animation of how the jet stream is being affected by climate. But anyway, first of all, does anybody else have comments or questions?
Valdi, there's a number of things in the chat.
Okay.
Can you take a
I'll
look
take a
there?
look. All right, let's see. You should consider making a bullet point YouTube video that is shareable on social media. That's an idea. I don't know what's involved in that. I don't know if we can take this directly and put it on YouTube. but that's something to think about.
Hey,
I see
Valdi,
Melody.
it's Sammy. It's your friend Sammy. I want to say thank you so much for the invite to be able to come tonight. My knowledge is mostly on being, an activist as far as social justice and criminal justice reform. So I've been trying to learn more about climate change, and so that's really actually why I came tonight. So everything that you said was, I really learned a lot. And I just think that if there was a way to like condense it down and to get it shareable, I think that would be really great. Just kind of to kind of give people some like quick bullet points and stuff to get them maybe excited and stuff. But the visuals that you gave were really great. And for someone like me who's like kind of just trying to learn a little bit more, I would have loved to see it like in a YouTube type thing that we could share. So if that's something that you'd ever do, I think that would be really great and a really great educational tool. So I just wanted to say thank you. Thank you for everything you taught me tonight, and I appreciate that. Have a good night.
Thank you, Sammy, and thank you for coming, and thank you for caring, and thank you for all you're doing in the social justice area as well. So it's really difficult to condense such a complicated subject down even further than this. I had trouble feeding it into this low a time period. So I think if people look at the slides, I think that's could take them a long way. But anyway, I try to look at more on this. Let's see. Melody Maynard talks about Hampton Dutch dialogues regarding sea level rise.
That was
You've got-
just to give you guys something else to look at if you're
Okay.
interested in it.
All right, thank you.
Valdi, you've
Uh,
got a raised hand. I see. Chris Berger.
Oh, Chris Berger. Okay, go ahead.
Hey, Valdi, excellent job. A lot packed into it. It probably won't surprise you when I say, one thing it seems like we consistently leave off the table when we're talking about things people can do. I keep on trying to get people to visualize the pie chart of energy use, and we use 38% of our energy producing all the stuff that we consume day in and day out. It's not glamorous. We're focused on buildings, we're focused on transportation, all good stuff. But if we just would reduce the consumption, number one, and number two, just not consume in this linear fashion that we continue to do, we would save so much energy just simply recycling and getting stopping the constant extraction and manufacturing of the resources. So the other part that fits into that when it comes to waste is again you mentioned the methane in the permafrost, which is, it's super scary. But we're always generating methane from our landfills. And that's a direct result because we put all our organics in the landfill. So that would be another easy thing to just stop doing, but we never put it in the list of things to do to address climate change.
Good point, Chris. I'm sorry I left that out of it, but yes, if we reduce our consumption, that's sort of the same thing as not using energy, because if you reduce consumption, then of course that reduces the energy it takes to make whatever you're buying. So that's the other thing too, that if you're considering buying an electric vehicle, don't just do it because if you have already a perfectly usable vehicle that you just bought. If you got an old vehicle, yeah, it's worth buying an electric vehicle that needs to be replaced anyway. But if you've got a brand new vehicle, please don't replace that with an electric vehicle immediately. Initially that's not going to help. In the long run, it helps, but you're taking.
I got an old vehicle that I'm going to replace with an electric vehicle. very soon.
Yes, yeah, no, that's fine. That's perfectly
about that, I
appropriate.
know.
Yeah. All right. I'm going to see if there's anything else on this chat here. Julian, go ahead.
Just a very quick follow-up to Chris's comments. There's a wonderful little, I think it's about 20 minutes video called Story of Stuff. And I'm sure some of you know it, but it's got some very nice humor in it too. And but it makes Chris's point very graphic. And I recommend it. You can just bring it up, just Google it, Story of Stuff.
Actually, I
And
was a
it's great to
consultant
share.
on that, Julian.
What's that?
I was a consultant on that.
Yeah. Great.
Very good. Doug, you have a hand up? Doug, do you have a question?
No, that was just a thumbs up for the previous speaker and one for you.
Oh, thank you. Very
We
good.
got here late, but thank you for doing this.
Thanks, Doug. It's good to hear your voice. We've gone back and forth via Facebook and Messenger. So thank you for attending. It's nice. You're in New Hampshire, so we're so far attendees stretch all the way from Virginia to New Hampshire. So it's good to see that my impact here is not just in the Binghamton region.
You've done good.
Thank you. Oh, and then we've got one person in Florida. I forgot Mike Fries too. He used to be local here, but he moved to Florida, so he's on the meeting too. So thanks, Mike. I see Robert Wright. Go ahead.
Yeah, I just think population growth ought to be in this conversation. It's not increasing percent-wise, but it's increasing number-wise each year. World population.
Yeah, that's a major problem, and some people are talking about that. It's a touchy subject, though, especially viewed from the point of first world nations trying to look down on third world nations where the population growth is higher. It's a little guilt-inducing, depending on how you say it, and kind of condescending for us that have already created much of this problem with a relatively small population, and now we're telling people that are already struggling, and they're having more kids than we are having now. We used to have families of 6-8 kids when we were mostly agricultural, many based on farming, and they're based on farming. So when you have farming, you have kids doing the work in the farm. So it's a touchy subject, and it is worth talking about. And the one thing that we can at least do is provide birth control. And of course, there's a certain political party that doesn't want to participate in that either. So it becomes complicated. But I agree with you that population certainly is a problem, and we need to level that off quickly. That'll help a lot too, because all of these things that I talked about we're already straining at the seams, even without the climate change problem. Go ahead, Bruce.
I agree with you. We need to encourage birth control, population, try to bring it down in respectful ways of culture and everything, but we do need to bring it down. The flip side of it is we also have to acknowledge that the American lifestyle uses far more energy than many of these developing countries. And so we can look at people in India and China and Africa or whatever and say, you need to have less children. And they can look at us and say, you need to use less energy. It goes both ways. Everybody's got to do things.
Exactly. Well put. That's it in a nutshell. We are putting the biggest strain, per person on the planet. And when I say we, I mean the developed countries, including Europe, many other countries as well. Now China to a great deal as well, and some other Asian nations as well, Australia as well. So there's a huge number of them, but we have to be very careful how we go about trying to get the population under control. But it is worth doing, and certainly many nations need help. with medicine, with trust. And if you help people with knowing that their children are going to survive, they will naturally have less children as well. If you have 2 children and you're pretty sure that they're going to survive to become adults, you're probably not going to want to have 3rd or 4th or 5th. But if you need help on the farm and you know that maybe perhaps 1 or 2 are likely to die or end up with some physical ailment that is going to prevent them from helping you, you're probably not going to reduce your family size. And then the other thing is, if women can't control, what's going on in terms of their reproductive health, they don't have access to birth control. The men are, kind of ruling the roost. You can't expect, things to get under control if women don't have access to birth control, especially if they don't have money to get it, or they can't even get to where it's available. So there's things we can do as first world countries to help this. And what I'm not showing you, but I'll verbally describe it quickly, that if somebody argues with you that, well, in the middle of winter, why are we having this minus 20 degree cold snap? And why are we having, 3 feet or 4 feet of snow or whatever? It's because the jet stream is getting bigger loops north to south, bigger swings, and it's the west to east movement, the eastward movement of these waves in the jet stream is slowing down and sometimes getting stuck. And when you get stuck so that the northern part of the jet stream is in the Arctic, way at northern Canada, and we are at the downward swing of this jet stream, then that's dragging Arctic air way down, sometimes to Florida. And if we've got warming atmosphere along the way, the atmosphere's got more moisture. The warmer air holds more moisture. So now you're going to get more snow. And you can get these cold snaps, and they can last for a couple of weeks if the jet stream is stuck. This has happened now over several years on a sporadic basis. And it was theorized back in around 2010, and it started to become publicized and studied, and papers were published on this, and it was picked up by media. So that's a real thing. There are still people that are kind of wondering how much of an effect this is having and how much worse it can get, but it is real, and that's related to climate. So, and if you're on the other side of the jet stream, then you can get these big heat waves in the middle of winter where we, and living in the Northeast, winters used to be more stable. Now we get swings of temperature into the 70s, in December and in January. That's ridiculous. And now it's happening, more commonly. We never used to get that kind of thing. And now it might happen multiple times in what is called a winter season. So this is still climate change. And what Catherine Hayhoe, who is a climatologist based in Texas, she calls it global weirding. And, things are getting weird. They're strange. And that's a big part of it. It's not just an even warming of the climate around the world, just a few degrees. It's some places it's a huge amount, other places it's a small amount. And when it affects air currents, ocean currents, big trouble can happen and strange things can happen. And you get these massive, weird rainstorm events. Just almost a little, like 1 month past 10 years ago, we had a massive flood that inundated a Air Force Plant 59 that used to house what was GE, was my former workplace, and eventually became BAE Systems. And that was a 620,000 square foot factory building that was built on elevated fill, and it had a partial basement, and it was protected by a levee that was built after some flooding roughly half a century ago. And in 2011, a remnant of a hurricane, it was a tropical storm here, it was called Tropical Storm Lee. That storm got stuck and for roughly 2 days, we had wave after wave of heavy torrential downpours of 1 to 2 inches per hour. So we had basically a foot of rain in a little less than 2 days. So the Susquehanna River rose over 20 something feet, 25 feet, 27 feet in some areas, and it came over those flood walls, levee systems, and inundated this plant that had been in existence since the beginning of World War II, and flooded the plant with 42 inches of water, and basically it ended up being demolished. My workplace had to dismantle and pull everything out in humid, hot conditions, wash everything, and then find a new place to set up manufacturing again. And this was a horrific event, and that's bad enough, but many people lost their homes. There was a picture that I found that I didn't share in this presentation, but it's dramatic too. We had temporary climate refugees on cots and on the floor of the local Binghamton University Event Center, which is basically a big basketball arena. That is mainly what happens in there. So it's not just New Orleans. If you live along a river, you can end up with temporary climate refugees too, and eventually people losing their homes and businesses. And this is happening across the United States. People are dying from wildfire. They're dying from heat waves. They're dying in their homes. They're dying in their basements. You know, it's just people that they'll still argue about this are morally reprehensible.